I'm going to be talking about Atproto Ethos, which is essentially the philosophical and aesthetic principles underlying the design of the protocol. So before we get started, my name is Daniel Holmgren. I'm the head of protocol here at Blue Sky. You can find me on the Atmosphere at dholmes.xyz. And for the freaks out there, you can find me at thisdid. So the title for this talk actually came from a thought that I had whenever I saw Martin post this. He said, whether something is decentralized or not is a function of the administrative control of different parts of the system, not a function of the network topology. And this just struck me so hard, and I was like, yes, this is exactly what we're going for. I actually brought this up to Martin a couple of days ago. He didn't even remember posting it. I'm like, I think about this every week, Martin. But I quoted this and I said, this is Atproto Ethos. And I do think that this is very descriptive of the topology and the power dynamics in the network, but what it doesn't quite have is like a prescription for how to get there. And so this term Atproto Ethos kept coming up in our protocol design questions. We kept kind of like, nice. We kind of kept coming back to it whenever we were weighing different options. And I wanted to take the chance to try to dissect what that ethos is, the historical influences on the design of the protocol, some of the new things that we brought to it, as well as some of the postures that we adopt as we are working on the design of it. And just for what it's worth, not all of this was like perfectly packaged or anything from the beginning. We had like a million false paths and dead ends and hard debates between team members and everything. And maybe in a future talk, we can give the philosophical history of Atproto, but I'm gonna give you guys the nice clean packaged version of it. So I would sort of situate Atproto at the center of three movements or three trends and influenced by those three trends. On the one hand, we have the web, then we have the peer-to-peer movement, and we have, I don't have a good quick word for this, but kind of large distributed systems or these data-intensive applications that kind of run the modern web. I also didn't have a good picture for that, so I used the boar from Martin's book. So we'll start with the most obvious influence, which is the web. As I'm sure you guys all know, the web is an information system for publishing documents over the internet. So if you have a static IP address and you have a server, you can host a document. If you have an internet connection and a route to that server, you can fetch that document. Kind of the incredible thing about the web, the defining feature of it, is that it's completely permissionless. That's the only thing that you need to publish a document. That's the only thing that you need to go fetch a document. Location is also based in the authority. We layer on DNS on top of those IP addresses. This sounds really obvious to say out loud, but you know that a document is the thing that you get from a server because you talked to that server and the server gave you that document, right? But the authority rests in the location that you talk to whenever you're fetching the document. This combined with the permissionless of the web was actually a pretty radical idea. You didn't need any central publisher, any central distributor. You didn't need a certification checklist to say that you could publish a document or anything like that. If that permissionless and openness was the defining governance feature of the web, sort of the defining product feature of the web was the hyperlink, which gave you interconnected data. Documents could link to other documents, and specifically they could link across authority, again, completely permissionlessly. The downside of all of this is that servers are hard. These all run on servers. Not everybody knows how to run a server. Not everyone can get a static IP. Not everybody can configure DNS. And so what we started to see emerge in the modern web, or what people call Web 2.0, is this move from permissionless publishing to platforms. Everything running on a big server called bigsocial.com, which I thought about making a BS joke, but I thought that might be dangerous with the name of our company. So these platforms were account-based. You'd register an account with one of these platforms. The benefits of it is that it's very easy to post. You don't need any technical knowledge. You just need an account on the platform. You have rich media, photos, videos, music, interactions, dynamic real-time interactions between accounts on that data. And then to top it all off, a nice algorithm that churns through all of that data, shows you exactly what you want to see, crunches all those like counts, the reply threads, everything like that. And I don't want anyone to think that I'm like doughy-eyed nostalgic for Web 1.0. There's a lot about the modern web that is really great. Nobody wants to go away from that, but there was also something that was lost with it. So that kind of takes me to the next influence on Atproto, which is the peer-to-peer movement. In a lot of ways, this was a response to what was happening in the modern web and that sort of centralization in these large social platforms. And the basic question that it asked is, why is there a server in the mix? So I have me here and Devin over there. I'm writing a post, Devin follows me. I want to send that post to Devin, and we say, why is the server here? What if we just removed it and I sent the post directly to Devin from my phone to his phone? And the question that came out of that is, can you build a modern social network without a backend? This kind of came from a distrust of these large centralized services and platforms. And so if Paul, Devin, and Brian are all following me, I make a post, I send that post out to the three of them directly from my device to their device. Of course, there's a problem there. If I'm not online at the same time as them, how does my post actually reach out to them? And so these peer-to-peer protocols said, well, if I sent my post to Paul already and I'm offline and he's online at the same time as Devin and Brian, then he can forward on the post to them. Of course, the problem with that is that what if Paul replaces my post with a poop emoji and sends that to Devin, and that's really embarrassing for me. I don't want Devin to think that I posted that. And so these protocols would get around that by introducing public key cryptography, signing the message, which essentially put the certification that the message is what I intended it to be in the message. Every account would have a public key associated with it, and it gave me the liberty to broadcast my message out and trust that other people could deliver it reliably without altering the contents of it. Then in a lot of these protocols, you would then get content address data. You would sort of build this abstraction around the routing of these messages. Since you could get them from anywhere, the certification is in the data itself. You would reach out and you would say, I know that there's this piece of data with this hash, and you would reach out to the network to go fetch that and grab it from some device in the network. What this gave you whenever it was functioning well is this really beautiful abstraction. It's what drew me to the peer-to-peer movement in the first place, which is it completely dissolves away the network topology, the devices, the locations, everything like that. And there's like kind of this essential essence to these posts that are and you can just reach into the ether and pull them out. It's like a really beautiful thing. It's a really beautiful concept whenever it's working well. Of course, that's if the abstraction's working. A lot of the times it doesn't work well, and you have data availability problems, data routing problems, things like that. And then the big problem is that phones are a lot smaller than data centers. And we have these big machines in the cloud that are crunching all of this data for us, and phones just cannot keep up with that same data. You have resource usage problems, battery life problems, and then you just can't store all of that data on your phone, so you're not going to be able to create the same global views that these big social platforms are able to create. Excuse me. So that brings us to the last influence on Atproto, which is the parallel development that was going on while these peer-to-peer protocols were kind of being worked on, which is how these large distributed systems that underlied the modern web were being architected. So sort of the features of these is that they have millions and eventually billions of users, real-time dynamic views. Someone likes a post, you get an update on that milliseconds after the fact. They're very, very read heavy. For every post that is posted, it might get loaded thousands or millions of times. And there's very high expectations whenever it comes to downtime and latency, especially as more and more of the interaction on the web started centralizing on these platforms. So we needed new techniques for building these data-intensive applications. Martin Kleppmann's book, Designing Data-Intensive Applications, is kind of the Bible on this. He gave a really great overview of all of the trends. I'm going to talk about kind of high level the trends. Obviously, all of these platforms are architected differently, but maybe we can suss out some of the commonalities in a lot of them. So maybe one of these platforms starts out with a server and a big Postgres database. And the first thing that you're going to run into, because they're so read heavy, is that you want to split out the read and write loads. So here we see that database getting some read replicas. All of the writes are still coming in on a leader database. The reads are getting pushed out to these read replicas. You can scale up reading separately from the writes that are coming in. A lot of these platforms started to decompose their monolithic services into microservices. You would essentially peel off some piece of the service, wrap it in its own service. The monolith or the main service would then call into it. There are a lot of reasons to do this, organizational reasons. You could have small teams own code bases. You could also scale resource usage according to what that service did. Video transcoding looks very different from timeline generation. And you could put these on machines and give them resources that matched what they needed to do. Of course, whenever we do this, all of a sudden, we just created a distributed system. And whenever you have a distributed system, you have distributed problems. You no longer have strong consistency necessarily between all of these services. If one of these microservices goes down for 3 hours and it comes back up, did it just miss out on 3 hours of writes? Is it ever going to get back in contact with the same data that the other services in the data center have? And so we find these services starting to lean into eventual consistency. And oftentimes using eventually consistent databases as well. I put Scylla here because that's what we use at Blue Sky, but it's a successor to Cassandra. There's other databases of that type as well. And these kind of give up on the ACID guarantees of Postgres or something like that, give up on the ability to linearize writes, and really focus on being able to do low latency writes and reads. Another aspect of these is that you also give up on the ability to dynamically query your data. You kind of have to be aware of what your application is going to ask of the data before you lay it out in your database. That means that if you need a new index or you need to re-index stuff, you have to reprocess all of the data. If the data is already in the database, how are you going to do that? A lot of these problems were generally solved by an approach of stream processing. I called out Kafka here, but again, there's other examples of that. And this kind of introduced a information flow into these backends where writes would come in, they would get added to the stream processor, and then filter out to the microservices or the database. This meant that if a microservice went down for 3 hours, it could pick back up, talk to this canonical stream of data, and catch back up, know that it has everything. Similarly, if you have to rebuild an index or build a new index, you can just replay the entire stream of canonical data and know that you have everything in that index. These canonical stream processors sort of served as the backbone to these data centers that could give the feeling of consistency in them. So this brings me back to Atproto Ethos. I would say that Atproto Ethos is sort of situated as the synthesis of these three movements. So it's influenced by all of these movements. From the web, we kind of took the fact that it's open, permissionless, and it's this universal network of interconnected data. From the peer-to-peer movement, we took location independence of data, the fact that the data is self-certifying, it has the certification embedded in it, and this general skepticism of centralization. And then from these large data-intensive distributed systems, the splitting of read and write load, large application-aware indices, decomposition of stuff into microservices, owning up to eventual consistency, and stream processing. So now I'm going to get into the new things that Atproto brought to the table. The first is identity-based authority. Again, this is in contrast to the location-based authority of the web or the content-based authority of peer-to-peer. We said identity is in primacy. So the central thing is my account at dhomes.xyz, and then the thing that you'll find there is all of the social data contained inside of it. With this came a change in addressing scheme. So in the web, we have HTTPS. It points to a location, bigsocial.com, and then you fetch my profile from that. A peer-to-peer protocol like IPFS points to a hash of some data. In Atproto, it points to dhomes.xyz, which kind of looks like a location, but it's actually an identity, and then it points to the record type, the collection, and the key of the record inside of that. Similar to peer-to-peer protocols, this gives you location-independent data. Every identity, even if it looks like a DNS name, resolves to a universal identifier that is independent of location. And then that identifier, in turn, resolves to the location where the data is stored and key material. So we essentially introduce this layer of indirection between the identity and the location of the data. And that lets these identities kind of float on top of the data, abstracted away from the actual or the actual topology of the network. Because they're floating on top of the network, they're able to migrate between locations that actually host the data or host that signing key. And identity is really the primary thing that floats atop this layer of hosts. And then from the web, we kept interconnected data, and similar to how the web has interconnected data across authorities, Atproto also has interconnected data across authorities, but those authorities are identities, and the data is structured schematic data instead of document data. So the next thing that we introduced is this notion of generic hosting and separating application semantics out from canonical data hosting. So this is my identity that we saw earlier. It has some likes, follows, posts, and images inside of it. From the perspective of my data hosting server, my PDS, it just looks like this. They're just CBOR objects. It has no idea what the rich application semantics inside of my repository are. It just goes, this is CBOR. What this lets happen is that application developers can then own their schematic space without coordinating with the host of that canonical data. So inside my repository, we have Blue Sky posts and smoke signal events and White Wind blog entries that are defined by the application, app.bsky, events.smokesignal, com.whitewind, not by the host that is hosting that canonical data. All of these hosts of data then exist in this very crawlable, very accessible network of open data, and applications can then reach into that data, pull it out, and imbue it with the rich application semantics that you associate with the modern web. So what this gives us is decentralized hosting and centralized product development. The hosts that make up this decentralized network are blissfully unaware of all of the rich applications that are running on top of it, but the rich applications can make choices that let them move like how you expect products to move. They can have, you kind of need to be able to have leadership whenever you're making a product. You need to be able to rapidly iterate. You need to be able to use the tools that you want to use, but you inherit all of the benefits of the decentralized hosting and the decentralized data where it can be extensible, remixable, reusable, accessible to other applications while retaining the benefits of having a clear leader for a given product. So the next two things that I want to go over are less like features or something that we introduced and more kind of postures that we took as we were approaching these problems. The first is kind of the acknowledgement that having structure actually gives you freedom in one of these open and permissionless networks. So Atproto is a multi-party, low coordination network. You have all of these devices and services talking to one another. And the question is, how do they all talk to each other and how do you come up to a coherent whole? You want to avoid the tyranny of structurelessness, which is essentially this collapse whenever you say, hey, it's really great, we have freedom, we can do whatever we want, and you have this collapse in coordination where nobody can actually get anything done because there's no clear leader to actually get that done. We want to spend our time building applications and doing cool stuff and not just focusing on facilitating interoperation, fixing weird edge cases, building defenses against bad actors, or trying to coordinate evolution whenever none of us have a clear leader that can do that coordination. So what you'll find is that Atproto is a very structured protocol. We tried to reduce the number of choices that you could make in the important areas in as many ways as we could. You can kind of find this reflected all the way through the stack. Just to call out a few of them, records are encoded as canonical CBOR. We inherit that from IPLD. The repository is this unicit data structure called an MST. Unicit basically means that if you have the same content inside of it, you'll always have the same root hash. It has a deterministic construction. Even just the fact that we used a repository that could hold all of the data so that you know that you have the full view on a user instead of these free-floating objects that you have to run around and collect. We have a constrained but extendable set of DIDs and hashes. So right now we only support one hash function. We support two did methods, but we use this flexible structure to encode them so that those can expand over time. But I think that this reliance on structure is probably best represented by Lexicon, which is our schema system. And we essentially took a schematic approach rather than a semantic approach. And I'll try not to butcher this too much so that the RDF people don't get mad at me. But a lot of the semantic approaches kind of try to define this universal ontology or interoperation between different apps. And here I have like 4 different possible representations of a post, and they all kind of look similar. You can kind of imagine how you can interpret them all in the same context. And the question is, are they the same thing? Can we interpret them in the same context? And instead of trying to build this universal ontology, we tried to give very specific tools for determining if you're talking about the same thing. So the approach of Atproto was to have schemas. Here we have a simplified version of the schema for a Blue Sky post, and then 3 examples on it. And you can see the first one passes schema validation. The next one looks nothing like it, so we say that's not the same thing. The third one, this Greengrass post, actually does match the schema, but it declares itself as a different schema, and so we say it doesn't pass schema validation. And what this does is it gets you out of the gray area. You don't have these questions of, are we talking about the same thing? This kind of looks like that other thing. Can we interoperate these? It says, black and white, either these things are the same thing and we're on the same page, or they're not the same thing, we're not on the same page. If they're not the same thing, an application can still use both of them, but at least we know that we're talking about different things in these 2 different contexts. And then the last sort of posture that I'd call out is what I call lazy trust. And this is this idea that you solve trust through checks and balances and credible exit instead of trying to operate completely trustlessly. This notion of being trustless was something that came out of peer-to-peer movements and especially blockchain movements. But you actually get a real benefit from trusting services to operate on your behalf. Doing trustlessly offloads that into compute or time or resources or something like that. And things just work better if you trust someone that's doing something for you. But you need to have the fallback in case they do you wrong. And also the existence of that fallback decreases the incentive for them to do something wrong by you. So here we have me, and I love my PDS, and I love Blue Sky, and I trust them, and I'm offloading some work to them. The relationship between the PDS and Blue Sky operates over the self-certifying protocol, so that part actually is trustless. But since we have a human in the equation here, let's try to save some time and resources. Now, what happens if my PDS goes evil, right? Fortunately, because identity is in primacy and it floats above these PDSs, I can migrate my account and signing key over to that PDS. The benefit of having this trust with the PDS is that we can hoist the signing key up from the client into the PDS, and there's a lot of benefits that come along with that. You don't have to do all of the horrible key management UX that nobody quite has figured out yet. And whenever I migrate my account, my signing key is living over there, and I'm happy, and I love and trust my PDS again. Similarly, with the Blue Sky app view or the Blue Sky app, what if it goes evil and starts serving bad views of the data? Or what if it just starts making bad product decisions? The Blue Sky app view is operating on the same open data that any other application in the network can run on, and any other application in the network has access to. So whenever the Blue Sky app view is serving views of that data, it's sort of staking its reputation on every view that it serves, and it can be called out on that. Similarly, if it starts making bad product decisions, someone else with access to the same data can start making good product decisions, and people can start using that application. So if the Blue Sky app view does me wrong for whatever reason, hopefully people here start running a self-hosted Blue Sky app, but people can move over to another application that is using that data in a way that matches with their user expectations. So wrapping up, I kind of already went over the influences from these movements, but I would sort of situate Atproto at the center of these three movements, influenced by the web, the peer-to-peer movement, and these large distributed systems that underlie a lot of the modern web. The things that we introduced to it are identity-based authority and this split of generic hosting of canonical data from the rich application semantics on top of it. And then we tried to approach a lot of these problems erring on the side of structure in the protocol, understanding that that helps facilitate coordination, and relying on trust with services, but always having credible exit from those services, and using that as an incentive to keep people playing along with each other. So thank you.
Awesome. Thank you so much, Daniel. All right, let's get to questions. Anybody have? All right, we'll start with Chris.
It's kind of a question, but one of the things that we found really common in the early days of the web when we were studying how people were using HTML and HTTP to share information and what the browsers were forced to render despite the incorrectness of the schema was also the thing we found that really helped the web grow astonishingly fast and in a distributed and decentralized manner, right? So when I saw your thing about, oh, this schema is conformant, this one's not, so we can't render it even though we could if we wanted to. Are you hitting any of these parts where you're like, if we just accept the misspelling of the schema, we can get this content up the way that the people are intending? I'm wondering if you're hitting any of those kinds of funny spots.
Yeah. And I mean, there always is a tangle there because, I mean, we ran into that, for instance, with timestamps. And like some clients were putting up timestamps that didn't match our schema. And that is really unfortunate to deny those. But the other side of that is if we start accepting those, then every single client, every single service needs to be able to process those timestamps, right? And so it's this question of, okay, do we let this piece of data through that we can kind of understand, or do we put the implementation burden on every single other client and every single other service to be able to understand that type of data? And what we err on is that fail early, give people feedback that this does not pass validation, and you keep that implementation burden off of all of the downstream services.
So I'm gonna I want to get your take on the question I asked Nick earlier, which was around compositional APIs. So like I totally agree with you, like having strict API contracts with data is super important, and it makes it a lot easier to develop against. But then the thing that I've seen in a few ecosystems is if you get too strict on like, well, this is what the API is, and it has these 15 fields, then if you don't satisfy all those 15 fields, you're not talking the same language. And so I'm wondering if there was ever a thought around, like, instead of just having a single schema as a spec, having like a list of schema objects that represent the data contained in that document.
Yeah, that's a great question, and you sort of run into a lot of the same data modeling things that people do in like more centralized systems with like protobufs, for instance, where there's kind of this rule of thumb that you shouldn't use required fields because they're hard to evolve. And that's something that we've learned as we're working on our lexicons, is that I think that we use less required fields than we did early on. We put more stuff in open unions whenever even whenever we don't really need it, or just structure things in a way that it's more likely to be backwards compatible. I do think open unions are sort of like they're the extension point for lexicons, and I think that they give you a lot of freedom for what you're talking about. And that's kind of, I think, what you're getting at, is embedding schemas inside of, embedding like maybe smaller schemas inside of the routes that you're talking to. So yeah, I definitely agree.
Hi. Oh, yep, Nick Jarakinis, stuff, great. Two thoughts, or two questions and thoughts, I should say. First, what are your tactical and strategic plans or thoughts around improving the safety of users with rogue PDSs? It's like if a PDS decides to, yoink out and delete your stuff, then because it has the keys to your PLC DID, you're up a creek. And then second, what are your thoughts and what's the calculus around infrastructure that becomes a bad actor, not necessarily the app view or the PDS or the systems themselves? What if, for example, as routing through North America, two providences have to deal with, that?
Yep. So on the first one with rogue PDSs, I do think that you take on some responsibility whenever you migrate to a new PDS, whether it's one that you run or whether it's one someone else runs. The fortunate thing about Atproto is that you can scale up in that responsibility and kind of take it on whenever you're ready for it. I think a lot of this comes down to tooling and having good tools for setting up recovery keys, good tools for backing up your repository, for auditing the PLC log and getting an email or a push notification or something like that if a operation happens on your identity. So yeah, I think a lot of it comes down to tooling on that. I think that hosts should offer that. I think people interested in the hosting space should build stuff like that. I know I want to work on stuff like that. But yeah, you do take on some responsibility whenever you migrate your account off, and then it's just building tools that make it easier to do that. In terms of underlying infrastructure, similar to how the web is kind of like predicated on the security model of the architecture of the internet, like Atproto is also predicated on the internet. So to some degree, we can't really solve routing issues at the internet layer. We do layer on additional self-certifying mechanisms on top of it, so it's not like an ISP can corrupt data or something, but they can do a denial of service attack and prevent packets from getting through. Yeah, I do think that there are bigger problems, but hopefully someone can set up something that can get the packets through.
Hey, do you see it as the responsibility of the protocol to sort of define some semantics for, well, you mentioned like timestamps, for example, as one of the things that one app view might do one thing and another app view might do another thing, but there's all kinds of things like deletion of records or just like what it's not entirely predictable just based on what's in the lexicon, what an application might do with a given like pattern of writes, or say, you rewrite a record, like does that show up as an edit? Does that show up as does it get cached? Does only the first version stick around? Like, do you see those as like conventions that ought to be defined in the protocol or just by like app view authors, or is this something that you've given any thought to?
I think most of those get defined by lexicon authors. There's some semantics that are in the protocol. It's like every record has a URI, every record can be created, updated, or deleted, stuff like that. But a lot of those application semantics are defined by the lexicon developer. And kind of my sense is that you should be able to look at record schemas and the methods that come along with it and basically have an idea of how an application is constructed. And then also projects like Lexicon Community and LexHub and stuff can provide further documentation on how you're supposed to process stuff. For instance, in the Blue Sky case, like blocks, what exactly are you supposed to do whenever there's a block? Providing further documentation on that for applications to build on.
Hi, I'm Eric. So I'm just curious, so you're talking a little bit about rogue PDSs, credible exit, that sort of thing. I'm just curious what your general thoughts are on, these are really important things to users in particular, and they should be things that are better understood by users in particular. What are your thoughts on enabling users to understand the fundamental underlyings of the protocol and the fact that there are options available to them when bad actors come into play, especially with looking into how people might consider self-hosting or doing these sorts of things that are potentially more technical for the majority of the user bases of, whether it be Blue Sky or any emergent platforms on the protocol. So I'm just curious what your general thoughts are on, how can we make people aware that this is how the network works rather than a Twitter 2.0 centralized service?
Yep, totally. I mean, I think that the thing that you can't do is force users to understand that, right? You have to give them the ability to gradually ramp up. And so it's like, you have an account on the protocol, that's great. Okay, you set up a recovery key, even better. You're doing backups of your repo, even better. Okay, you're self-hosting your account, wow, even better. Okay, you're doing that and you're using a self-hosted application, awesome, even better. So you need to give this on-ramp for users to gradually adopt more responsibility for their experience in the protocol, but you can't thrust all of it on them at the beginning. And then it's just a question of building good UX around that, making it approachable, figuring out how to explain the ideas. I think that there are ways to do it. It is a hard question.
I joke that Blue Sky is a hat that looks like Twitter sitting on top of a distributed systems company, but it's a skeuomorphism that people can understand and recognize, and
yes,
gradually introduce people to how weird we can get.
Yep.
Yeah, go see Ms. Boba's talk as well.
Hey Daniel, Samer here from Fedica. I have a question about car files. Do you guys plan to continue to use car files in the future? And if so, because they're a little difficult to work with from the developer community. And if so, do you plan to make it easier, just like how Jetstream made it simpler than the Firehose?
Yeah, I do think that we plan to use car files going forward. We really want to write our own car library that has better interfaces. The current one is not very great. Yes, we do want to use them. Yes, we want to make them easier to use. And then on your question of Jetstream, my hope is that we evolve Jetstream into a larger, broader purpose, like sync facilitation service that not only provides this JSON API of records, but also facilitates backfill and repo sync and some of these headier sync operations.
Other questions? Otherwise, I definitely have a question for Daniel. I'm interested in hearing more about how you define the fear and the sort of threat modeling, right? One of the exciting parts about the approach that y'all are taking as a company is something that Brian Fitzpatrick talked about with the Data Liberation Front at Google, and the idea that companies should always make it possible for their users to be able to migrate away, because that is the way that you can say your users are affirmatively committed to the decisions that you're making and why you're, that y'all can maintain alignment and that you're not just trapping them there, right? When it comes to how you're thinking about that, both at the protocol design level, how evil are you imagining that your apps can get? How does that actually tangibly manifest in the way that you're thinking and sort of threat modeling the types of bad actions that you could take?
Yeah, totally. I I mean, I don't know how evil they can get. There's messed up
Well,
people.
That's kind of the thing, right? Like the threat modeling part about this is like, I worked with journalists for a really long time, and journalists can have any conceivable threat model from like, I only work on public records, and like, I don't care what people see, all the way to like, if anybody finds my files, like somebody's gonna get their fingernails torn out, right? And so like, the thing that impresses me about the way that y'all think about design is the decomposition of the problem space, and so figuring out how to tessellate out like which problems you want to threat model, I think is an interesting way that you go about this.
Yeah, totally. I think like the big way that I think about it is that since you always have that credible exit, it prevents one, rent-seeking behaviors where people can abuse their position as like some central provider, and it also gives an incentive not to abuse users on your service, and it also gives the ability for people to make very bespoke services to fit certain needs. So if someone has a very high privacy need, they can use a service like that and interoperate with the rest of the network. So I don't know, maybe to compare it to like messaging systems or something, it's like my aunt is never going to use Signal. There's nothing I could do to convince her to do that. But if I'm very privacy conscious, it would be great if I could use Signal and still talk to my aunt. And similarly, it's like if someone has like very high privacy needs, with this choice of service, or high privacy or data security needs, with this ability to choose your service, hopefully you could choose a PDS service provider that is really tailored to those. So yeah, I think that the choice of service gives you a lot of optionality on that.
Cool, thanks. All right, other questions? Otherwise, we'll say, yeah, come on over.
Proton PDS.
Daniel from the Bay. So I had a conversation about this earlier in the week. Boris had chimed in, but more so a non-technical question. How has Blue Sky discussed how to signal to people that they can sign in to like an app, for example, with their PDS? Like, let's say, for example, you meet someone who doesn't know what Blue Sky is, but they're signing into an app, or they're at the login screen of an app that is on the AT protocol. How do you signal to them that they can sign into that app? Because you can't say sign into Blue Sky.
Yeah, totally.
Like, what is that, right?
That's a great question. That's a UX thing we need to figure out. If people have good ideas on this, I definitely want to talk with them about it. But the great thing about Atproto identity is that it can serve as this universal identifier, both for social apps that run on top of the app protocol, but also for non-app protocol apps. And figuring out some UX pattern to be able to posit it, like sign in with Atmosphere, but that's kind of wordy and confusing, so we got to figure out a good one. Yes, sign in with cloudy @ symbol.
Because in the GitHub discussion, I know there was a specific mention that, I believe it was Jay, that mentioned that she didn't want Atproto actually used as, like, for branding. So, someone mentioned, someone mentioned that Leader said that she didn't want Atproto used for branding, or that branding, that Atproto shouldn't be used for branding. So I was just like, well, what should we do?
Yeah, I'm actually not quite sure on the context of that, so maybe we can chat about it after. But we definitely do want people to understand the atmosphere and have a coherent conception of the atmosphere, know that you can log into stuff with the atmosphere. And I do think a lot of that is going to be the brand and apps being able to use that brand.
This is also one of the things that came up in one of the tech talks that Boris hosted a couple of months ago, and I definitely also see that this is a community responsibility in part, and this is one of those things that we can work on, we need to be able to work on together, but also you'll have the largest install base, right? So
yes, totally.
We're interested in engaging y'all on that more. All right, I think we've got time for one more question if anybody's got them. All right. Okay, we can do two.
So I think it's in the lexicon community, and maybe Nick can correct me, but there is a GitHub discussion on this topic, how to improve the UX and the UI flow of logging in through other methods. I forgot the link, but I think it should be under one of the discussions under the lexicon community GitHub repo.
Cool, thanks.
Hi. there was a long list of like previous references that informed the Atproto ethos. I'm curious if there are protocols out there today that you think are Atproto-y or share similar values or just things like that.
I'd say surprisingly, Nostr actually has a similar architecture to Atproto in terms of having relays broadcasting stuff out and aggregating it in applications, although they don't really have the like very rich backends that Atproto has with app views. But it sort of has a similar shape of information flow. I don't know, the web still?
Yeah. Thank you very much.